Excellent. Okay, let's go. So hi, I'm Matt Estela from UTSALA. I'll be talking about how we used Houdini, USD, PDG, and Lops at our studio. Hopefully this will give some interesting examples of how we use all these tools and how you might use them at your own studio or school. Also, as a special guest, you might see in the corner there, I've got Ben Skinner.
Hello, hi, yeah, Ben Skinner. I'm a ALA ex-Pipeline TD and alumni, and I'm currently in Canada working in an animation studio here.
Cool. So Ben had a pretty instrumental role in all of the tech that you're about to see. So let's get started. So first of all, just to give a bit of background about us, the UTS Animal Logic Academy has just started its fourth year of students. We run a one-year accelerated masters. And you can see here the kind of stuff we do. We do film, we do real time, we run like a studio. We intentionally have the students and us make lots of mistakes. We do lots of versions. We create high quality final results. We work in really big teams and we get people ready for industry. We also do research and industry consultation. But let's first talk about USD. So our story with USD started in our second year in 2018. Our first year was based around Clarice, Alembic, and JSON files, which worked, but there were several pain points, and they were going to need quite a lot of work to solve. Dan Flood, our tech lead, looked at USD and decided it was worth investigating. This worked out really well. We managed to simplify a lot of things that were tricky or actually sort of impossible before. So things like solid interchange between many apps, integration with a shotgun, faster loading times. We had a lot of success with a relatively simple implementation. In 2019, we decided to push harder on our USD pipeline, going into fur and hair and cloth, doing some more ambitious layout stuff, while at the same time trying to simplify things even further for all of our departments. Houdini and Lops played a big part in this. I'll show some examples now, but first a bit of a tease about why USD is great. So here I've loaded up shots CV50 from our 2019 project in a standalone viewer called USD View. This is like using mPlay or RV, but it's for 3D. You can see that it's smoothly playing back at 24 FPS, which is great for doing reviews. It has an outliner on the side showing that we have effects from Houdini, the camera from a virtual production rig built in Unity by Ben, sets from Maya, characters and props. The characters have a complex internal hierarchy that's been set up in Maya, and that all flows down the pipe. It shows curve geometry, instance geometry, some basic shading. We can also move around the scene. We can inspect things. And we can see here, if I'm checking out the pants of this guy, that for the clothing, down in the lower right there is a layer stack, which I'll talk more about in a bit. It's also worth pointing out that USD really is for all the things, in that it can contain everything required for a renderer. Part of the USD spec is that it can communicate in a standardized way with render engines. So here, I tell USD View to flip over to RenderMan. Oops. And RenderMan fires up. If I can make that video play again. Here we go. And RenderMan fires up. There we go. Showing me a pretty good representation of what we'll get when this shot is passed to lighting. This is an awesome ground truth QC. There's no ambiguities between departments. If it works here, it'll work in final lighting.
It is really exciting that USD can handle all the things, but from a pipeline perspective, it's probably, again, worth reiterating that for us, we kind of came across USD in stages. We started with animation caches and then slowly moving to cameras and whatnot. So like USD allows you to do everything, but also scale back and kind of add things as the pipeline grows.
Good point. So before we get to the Houdini bits, I'll point out some USD tech terms. So the terms we'll go through are asset resolvers, which are a fancy way of dealing with file paths, layering, the ability for USD to be nested, and environment variables in Shotgun and Houdini. So first, an asset resolver. So this is a fancy way of saying that USD can deal with file names in a variety of ways. The default is to refer to just regular paths on disk. So you might have C:/project sequence shot my.usd, or you can go fancy. So we went fancy and wrote our own resolver to understand shotgun queries. So this means that we can define a file name as a query like you'd use, say, in a Google search to say, give me the latest cloth sim for shot 50. And USD itself talks to shotgun. It gets the real file path on disk and it loads that. So here I'm using the USD Python API to ask for that and to get back a file name. I can also do this in reverse. So I can give the asset resolver a file name and it will return the more general shotgun database query for the file. We open source all this, by the way. So this is called Turret, and you should go grab it.
There's a series of videos on our YouTube channel as well, which go into more of the techie details and how we kind of handle shotgun templates and fields as well. For us, our primary use case was that we had latest versions pushing their way down the pipeline because of our relatively junior cohort. This was a great way that it kind of just went down and went straight into the further departments.
Cool stuff. Two other USD concepts are nesting and layering. So a USD file can point to other USD files, which can then point in turn to more USD files again. So here I'm opening up the CV50 USD file in a text editor. And you can see that in reality, there's no geometry, there's no cameras in here. It's just text that points to other USD files. So if you've used my referencing, it's kind of like that. But remember that this is all independent of Maya. This works in any application that understands USD. So if you get down to this section where the character is loaded, we can see that it's using those shotgun database queries, which are called tank queries, to ask for the latest animation. But if you look closer, we're using a preprint call here so that if other files exist, they get layered on top of the animation. So here, the fur will be laid on top of hair, which will be laid on top of cloth, which will be laid on top of the soft body animation, which gets laid on top of the animation. So that's enough of the USD terms. Let's get into Houdini. So let's look at how we did the fur. So here's how our students work with fur on our alien character last year. So we used Shotgun's integration with Houdini to load the effects for a shot. And we get an HDA that contains the effect setup. Shotgun also sets up some variables like $SG shot for the shot number, $SG sequence for the sequence, and so on. So make a note of that. That'll come in handy in a bit. So to do the fur, Liz Haddonfield first loaded in a USD file of the alien in a bind pose, then went through and set up groups that she used later for grooming and set up some surface properties for fur direction and thickness and so on. But then she hit a snag. Liz started the groom quite early, before the character model had been finalized. So rather than start from scratch and lose all her work, she modified the USD loaders, so modifying those tank queries that we just showed, so that her original one was locked to a specific version, but the bright green stream was pulling in the latest model. This latest one went through a similar grouping setup, which was fairly straightforward, but then Liz used an attribute transfer to copy the original groom information to whatever the latest mesh was. After that, she painted up some more maps, but wherever possible, tried to define stuff in a more procedural way. So in this case, she was using proximity. So she would make simple objects that had attributes that she needed, and she would transfer those onto the mesh. Finally, the guide hairs were created. And again, wherever possible, Liz would use procedural tools like the guide process SOP to style the fur. So her grooming would stay valid no matter how the underlying topology changed and was easily art directable. Liz set up grooms for long, medium, and short fur, which are all merged together. The final groom was about 2.5 million hairs. There's a little sneak peek there.
That's a lot of hairs. Can USD handle that many hairs?
Well, let's see. Well, yes, it can. The groom would be then deformed onto the actual shot performance. The guide deform SOP is pretty straightforward for this. So you would give it the fur, the model in its bind pose, and the animated model, and it'll just stick the fur onto the animated skin. Now, despite the fur density, we could process this in about a second a frame. And if we needed to, we could split the frame range across multiple machines. We also had a branch in this workflow where we could enable a vellum simulation. That's this little bit down here, which we use on a few extreme close-up shots. So with the groom done, it was ready to be published, which we did through Lops. Now we jumped into Lops fairly early, as unlike the previous year, we wanted more control over where the effects work appeared in the USD hierarchy. In the first year, all effects just got dumped into a top-level /effects location in the scene tree. Here, we could do some more cunning tree surgery so that the fur would be inserted into the character hierarchy next to the skin. So why do we do that? Well, it's less surprises for the lighters. They could start lighting before the fur caches have been created. They could set up light linking, visibility tweaks, and whatever else they needed. When the fur was delivered, it wasn't a new, unexpected, weird mesh at the top of the hierarchy. It was exactly where lighters would expect it to be. We could also create Renderman fur shader networks inside Houdini, assign it in Lops, and the entire network would be exported so that lighting would just get a fully working setup. What was really cool was that if they needed to tweak the fur material, they could open up that shader graph inside Katana, and the entire Renderman node network would be there able to be modified, which is super powerful. It was a similar story for our human character. So to prep for grooming, Steve would load in the static model. So if you look here, you can see that in the model and the animation cache, there was proxy geometry for the mullet and the eyebrows so that the animators could read the performance before we ran our hair sims. Now, ideally, we want to hide these proxy shapes when we publish our hair caches, but we don't want the lighters to have to worry about it. So again, little hint for what's going to come up. So Steve Davidson here loaded the mesh, printed it down to just the head, and used a paint sop to take up the areas he would be creating hair for. So Steve chose to use the standard groom tools rather than Liz's procedural approach. So, and this is a workflow that's more familiar to XGen or Shave and Haircut users. It's cool that that Houdini's hair tools lets you choose the best approach for the job. So Steve manually sculpted the guide hairs into position, generated hairs from this, and did some final tweaks and guide process tweaks to get the final mullet shape. It's a similar process for the eyebrows, the mustache, and the stubble. It's funny when you just put all of these basic things together, how much of the greasy, nasty vibe of the character comes through. Yeah, not a person you want to meet in a dark alley.
Definitely not.
The deform process is pretty much the same as before. So first we'd merge all the hair pieces together and give them a color gradient to make it easier to see in the viewport. We'd bring the mesh in, but this time using a trick with the shotgun variables that I mentioned before. So we'd bring in the static mesh from modeling and the animation mesh for the shot, and they'd be both fed to a switch node. The switch node would have an expression that counted the letters in the $SG shot variable. So if there were letters, we know that we're in a shot, so it would load the animation. If there's no letters, we must be testing or we're doing a groom, so we'd bring in the modeling mesh. This meant that rather than have separate HDAs for sculpting and setup and one for shots, we just had a single setup that works for both. So we would bring in the hair, the static pose, and the animated mesh, and the guide deform sop moves the hair to where it needs to be. It's very cool. The publishing was done in Lops again. Materials would be assigned, and we would make sure that this went into the appropriate location in the scene graph tree. So remember we talked about needing to hide the proxy hair geometry, the polygon mullet and the eyebrows. So USD has a really neat trick here. So even though in this case we're only exploiting the hair geometry, we can still make almost like dummy locations, dummy nodes in the scene graph tree, which have the same name and the same path as the proxy geo, and we can mark them to be invisible. So then when our USD file for just the hair is layered on top of the animation USD file, USD will say, well, these things have matching names, so I'll layer these properties on top, and so that'll automatically hide those shapes. The lighters don't have to do anything, animation don't have to do anything. It's a really great quality of life trick thanks to USD layering. So the cloth had a slightly different process. We would load in the high-res cloth, which we actually never got rigging to even sort of try to bind onto the base skeleton rig. So the cloth was always at the bind pose. We'd load the body at the bind pose, then we'd load the body animation, and we'd point deform the cloth onto the character. So Bo Parks and Nathan Barrett set up a workflow that would identify self-intersections in the body geometry and try to smooth them out before attaching the cloth. For the final step in Lops for publishing, we would again ensure visibility was on and correct before exporting out to lighting. We had quite a few branches in the workflow so that if we needed to run a cloth sim, that could be folded in as well, but we ended up not actually needing that. And here's the end results. The lighters in Katana just have a single USD node, and that pulls in everything required for the shot. They can then branch off to make whatever lights, and layer splits, and matte passes and stuff that they need to make. But ultimately, the task that had been quite difficult in previous years of getting all the things required for a shot was all just brought down to a single node. And here's the end results, the bounty hunter. In this trailer, you can see we really tried to push the visual complexity as hard as we could. So there's crazy amounts of assets and surfacing and effects. If we didn't have our USD pipeline and Solaris, we wouldn't have been able to achieve this in the time we had. So that was all 2019. What can we improve about the pipe in 2020? Well, there's quite a few things. We're definitely sticking with USD, and we plan to move our set building out of Maya and into Solaris. We want our assets to be more self-contained and reusable. We want to leverage PDG to do some of the heavy lifting, and we want our assets to be ready for real-time use. So for sets, we're planning to use the Stage Manager lot for rapid assembly, combined with this handy thing our TD Ben Skinner developed. Oh, hello, Ben, you're down there. A shotgun set piece library. The scene graph tree, the Stage Manager has built an ability to have a library of things on disk, but we needed something that could work live with our shotgun asset database, hence this tool. So here it is in action. So here I'm just creating a simple ground plane in Lops. I name it ground, then I append a Stage Manager and open up our shotgun asset tool. We can now just drag and drop assets onto our stage, move them around, create folders, and reparent things in the scene graph tree. It's really fast and fluid. Comparing this to the workflow for building sets in Maya last year, which was really painfully slow, this would be great fun to use. A big win we'll get from using Lops for set layout is the tight integration with rendering. So remember when I showed USD View and its ability to talk to RenderMan? So that is based on a USD technology called Hydra, and that is also built into Solaris. So our layout artists will be able to swap to RenderMan in the viewport, and if our assets have materials, they'll see it, and they can still edit and modify the set all live. Really awesome.
Very awesome.
And so here's how that works under the hood. In the way earlier that I showed that our shots were nested, so that a shot.usd file is actually a text file that points to other USD files. Our USD assets now contain subfolders and references to other USD files too. So there's one for geometry and another for the shading nodes, and also handles assigning those shaders onto the assets. So it's all pre-assigned, it's all ready to go. So to get the shotgun asset browser working, one of the first things Ben realized we needed was thumbnails for every asset. So now that making a procedural layout and lighting setup is easy in Lops, and running a process across many things is easy with PDG, then combine the two to make this thumbnail generator. So the PDG graph asks Shotgun for paths to every asset, every set piece. The Lops graph loads the assets, scales it to sit in a 1-unit box at the origin, renders it still, feeds that back to PDG, which then uploads it to Shotgun. Do you have anything to add about that, Ben?
The nodes are a little bit untidy on the right there, but they've been improved. No, it's all kind of self-explanatory, and it kind of feeds into the power of kind of PDG working in hand with Solaris. And there's quite a good shotgun integration in there too, which is kind of what we built on.
Cool. So we've been using PDG for other things as well. So here's a setup Ben made last year for PDG. Do you want to talk this through, Ben?
Sure. We needed LODs at first for our virtual camera setup in Unity in a real-time engine. And so using PDG, we kind of brought in all the set pieces, decided we wanted 10 variations, including the final finished model. And then we kind of just let PDG do its thing, and then we wedged it out. And so we used a little sub import there, which all it did was a poly reduce at varying levels of reduction, and then fed that straight back out as a shotgun publish. And then our asset description was then smart enough to have USD variants, which were called LODs. And you could switch them. A benefit of that, which was later on in the pipeline, was that we realized we needed to kind of reduce our memory usage in renders. So we were able to use these variants to cull everything outside of the camera frustum with existing tech that we'd developed.
Cool. And I've actually got a bit of a preview of that later, but it's fine, Ben. You're just
Oh,
going to steal my thunder. That's fine. It's fine. It's fine.
My bad.
This is a fun demo. So this is what happens when you click go on the thing. So lots of blinky lights. Blinky lights, blinky lights, blinky lights. It's probably
laid out nicely. It's that they don't overlap as well. I spent a lot of time on
that. So some of your finest work, Ben. Well done.
Yeah. My legacy.
And so here's the end results looking at it inside USD view. So we can crack open this model. We can look at its options and see that we've got 10 LED variants available. So as Ben was saying, it's on the thunder. This was first developed for our real-time stuff, but when we noticed that some of our shots for the final film were using too much memory, we could quickly go in, set a really low LED for things that were outside of the camera frustum, and we could bring our memory usage and our render time down, which is very handy.
You worded it much better than me.
Thank you, Dan. And so here's putting it all together in our first little test set for 2020. So this is still very much programmer asked, courtesy of the lovely Ben, but it's a good proof of concept. So we set up a top level name, which we get from Shotgun, and then we use the stage manager to pull in assets. Now, note here that we can pull in assets from any project from our previous years, put them into folders, do what we need to do to give them a nice layout. We can then pull in a single asset by itself, which is this tree here, and we can use some of the Lops scatter tools to create a forest over a height field, which I've generated inside this Houdini session. Then we may as well merge in the actual ground plane we've used for the terrain itself, merge that in, and now we have a full set. And so that whole thing being there, that can just feed straight down to an output. But this being Lops, we can preview the set with proper materials and lighting in RenderMan. So we can branch off here. We can add a camera and an HDRI. And even just with the OpenGL viewport, we get a pretty good approximation. But we can just flip the viewport mode over to RenderMan. And now any assets that have proper materials, which at this time was only the 2019 assets, will come in properly shaded. It's really, really powerful. The layout team are going to have great fun with it this year.
It will. And it is worth reiterating that branch off to the left there after the split isn't published at all. And that's thanks to Solaris being just powered by the nature of Houdini and its proceduralism. Because often you do want those cameras and lights to make like little adjustments as you're creating the sets, but you don't want them to be published. You just want the pure set. So it's really kind of handy that you can just split it out, do your work at a kind of a local level and not have to worry about the publish.
Cool stuff. And of course, we'll be doing some effects work this year. Here's a tiny smattering of the R&D the effects team have been doing for the first 2 or 3 weeks of the term while we get the story and animatic lockdown. You can probably spot a theme of what we'll be focusing on this year. Some of the other stuff, a bit strange, not sure what Sean's up to there. And that's the talk, really. So if you have any questions, if you want to know more about how we've done USD stuff, turret, all those things, please get in touch. Ben, anything you want to add?
I think you covered it very well. I think USD is great, Solaris is great, Houdini is great, all the greats. I'm not getting paid. I'm not getting paid.
Yeah.
But could be though, if you want
to. What a powerful ending to the talk. Thank you, Ben. All right. Thanks a lot.
Thanks.